What's up, everybody? So OpenAI just released a bunch of new developer tools aimed at helping you create AI agents. And in this video, we're going to walk you through the logic behind the new Responses API as well as the new Agents SDK and show you a few coding examples over how they work in the wild. Now, just a couple of notes. If you're only interested in the coding section part of the video, do jump to the timestamp that we show you in the video here. And more importantly, if you want to jump to the agents part only, jump to this timestamp here. Now, with that said, let's get started. So I'm going to first walk you through the logic behind the OpenAI Responses API and then jump into the Agents SDK. And essentially, the Responses API is meant to replace the Assistance API, which is already an existing API product that OpenAI provides. Now, one thing OpenAI did mention that the Assistance API will be deprecated in 2026, so you will still have time to be able to migrate many of your apps to the new Responses API in the next year. Now, a couple of features that the Responses API mentioned, that OpenAI mentioned that the Responses API had, is that one, it is stateful, which means that it conserves your conversation history, as well as allowing you to do multi-turn chats with one single API call. So you don't need to build any additional tooling to log your chats. More importantly, it provides anyone with the built-in tools that OpenAI developed internally, such as web search, file search, computer use, as well as function calling. I'm particularly excited about computer use because it will open up the field for a lot of more agentic use cases, and we will definitely do a deep dive on how to use computer use in future videos. And of course, the new Responses API is multimodal. It uses both text and images at the moment. I think audio capabilities or modalities will be available soon. Now, if you want any additional details, do check out the link that you see here. As you can see, they provide a lot of details over the Responses API, the type of built-in tools that you will have, as well as a comparison between the Chat Completions API and the Responses API that you see here. As you can see, the Responses API does provide file search, computer use, web search, and audio is coming soon. And just a couple of things, if your application is built upon the Chat Completion API, don't worry about it. The Chat Completion API is not going anywhere. And that this new API primitive that OpenAI is developing, the Responses API, is essentially just an additional way to use the OpenAI API. In this documentation here, there have pretty thorough documentation on how you can use the Chat Completions API and how it contrasts with the Responses API, as well as other noteworthy differences that you can see here. So I'll make sure that we link this in the notebook and you can check it out at your own time. Now, the additional release that OpenAI released, which is actually much more exciting than just the Responses API here, is a completely brand new Agents SDK. And what this allows you to do is build effective AI agents relatively quickly with a lot of abstractions. And here, some of the principles that OpenAI discussed for the new Agents SDK is one, built-in agent loop that allows handling tool calling. So the agent here sees the conversation so far, includes user input, includes previous tool results, system messages, so on and so forth. Then there's an LLM that decides to produce a final answer, right? Ending the loop. So it calls a tool when there's tool calling, as well as handing it off to other agents. And we're going to talk about handing off and what that means. And then once the agent produces a final answer or hands off the tool, the query to another agent, the loop ends here. And we're going to see that in action shortly. Now, another principle here, which we discussed already, is handoffs and the ability to set the logic of an agent. So, for example, what it allows you to do is to delegate a conversation to another agent. Think if you have a customer support bot or a customer support agent that needs to handle billing, tech support, different aspects of support, you can have multiple agents within this paradigm that each are specialized in one aspect of support. And depending on the original query, the triage agent, as we'll see shortly, will will delegate the task to any of these sub-agents, as we'll see shortly. Thirdly, what the SDK allows is to provide guardrails to run input validations. So in this tech support or customer support agent example, if the original prompt has nothing to do with customer support, the guardrails functionality will be able to stop the loop immediately and allow you to return an error message to the user or return that this query is not necessarily related to the agentic use case, as well as enables you to set verifiable outputs and kind of control the type of output that you can have here. And finally, helping you write native tracing and observability, so you don't need any additional tooling here. And what this does is that it records every step that the agent does, provides you a detailed log of what the agent actions here are, whether it's prompts, tool calls, call inputs and outputs, final responses. And this is super helpful for debugging, analytics, or storing conversation transcripts. You can check out additional documentation on the Agents SDK using this link here, which is linked right over here. And as you can see, there's a lot of useful documentation on how to approach the agentic use cases, and we're going to be seeing this in action. So with that said, let's get started. Let's start building some of these use cases, and we're going to start off with the responses API. So to get started, the first thing I'm going to do here is install a few packages. Now, I've already done a few of these steps here just to save on time. First package I'm going to install is the OpenAI Agents, which is a new package, which is the Agents SDK, as well as the OpenAI package. Now, all you need to do is run run this code cell here and these two commands, and then you'll have all of the packages installed. Second thing, we're going to import a few packages that are just useful for our work today. So we're going to import from OpenAI, we're going to import OpenAI, and then from agents, we're going to import agent, import Guardrail, Guardrail function output, and runner. We're going to see exactly how these work in the agents section, which you can skip to by following the timestamp on the video below. And then from Pydantic, we're going to import base model. And what this allows is just doing some data type validation for the agents. Then to require for asynchronous execution of agents, we're going to import async.io. To retrieve the OpenAI key, API key, we're going to import OS. And then to show a couple of images, we're going to show base 64 as well as the IPython display, the image and display functions from IPython display. And we're going to import JSON just to interpret some JSON files. Now, I'm going to run this here as well. I've already run this. And then the next step is to get access to the OpenAI API. And all you need to do here is just go on this link. If you don't have the OpenAI API already, press on this link. I'm going to exit here, this DataCamp Data Lab. You're going to press sign up, and then you will go through an onboarding flow where you will get access to your API key. Now, if you already have a OpenAI developer account, all you need to do is just go to your settings on the OpenAI account, go on API keys, and then all you need to do is create a new secret key here. I already have my test key here. Once you create it, you'll be able to name it, and then you'll be able to copy it here as well. Now, once you copy it, I want you to go on the DataCamp Data Lab environment here, press on environment, go on environment variables, press add your OpenAI key, add your value. So I'm going to press cancel here because I already have it in. And then essentially it will look something like this. OpenAI API key value. This is super, super important. I want you to name it exactly like this: OpenAI _ API _ key in all caps. Otherwise, the Agents SDK will not work. Now I'm going to press cancel here just to avoid any runtime issues, and then you're good to go. Now, one last tip, this is for security purposes on Data Lab. Make sure that the environment variables are connected. Sometimes they will be disconnected, and once you press this button, you will have a connect button. Make sure that it's connected, and then you are good to go. I made sure that there's instructions in the cell here, and just a couple of things. You're going to have access to this notebook. You do have access to the solution notebook right here as well, just in case you want to follow along. Now, one last step is initializing the OpenAI key. So for this here example, all you need to do is create this OpenAI _ key variable, and then use the os.environment function to get the OpenAI API key. And then this essentially will store your OpenAI API key. And then once, all you need to do is just initialize your client and using the OpenAI function, and use the API key argument to store your OpenAI key. I'm going to run this again, and then yeah, we're good to go. We have a connection to the OpenAI API, and we're able to start using the new responses API. So for the first thing I'm going to do is I'm going to use the responses API to generate simple text using GPT-4o. All of today's examples will be using GPT-4o. So first thing I'm going to do, I'm going to create a response variable, and I'm going to use the client responses dot create function. So here, as you can see, I'm using the responses API, and I'm going to choose my model, which is GPT-4o. And then I'm going to use the following input prompt. Write a one-sentence bedtime story about a unicorn. And then to be able to get the text, all I need to do is just print response, dot output text. So let's see what happens. Oh, I made a mistake here. Let's double check. Where am I going wrong? It's the responses. Sorry about that. So yeah, it's running here. Just made a typo. And as you can see, in a moonlit meadow, a gentle unicorn named Luna whispered dreams to sleepy stars, so on and so forth. If you use ChatGPT, this is not surprising whatsoever. Now, just a couple of things here. We do need to use the dot output text attribute to be able to get the text, but that's only it. Otherwise, you will get, I think, a dictionary with a lot of different items. Now, second thing that we want to see here is a multimodal input. So we're going to use an image, right? So if I go on this image here to a new tab, you'll see it's essentially a picture of the, I think, Brooklyn Nets and the Cleveland Cavaliers with LeBron James doing a layup. So I'm going to remove this here, and we're going to see how the OpenAI API, the new responses API, handles images. So I'm going to create a new response function. I'm going to, again, use client responses dot create. So I'm going to go down here, right? Model, I'm going to specify it to GPT-4o again. And then for my input, I will create a list, because I'm delivering essentially two inputs here, an image and the prompt, right? So the first thing I'm going to do is I'm going to define my role, which is user, right? And then the content here will be, let me just clean this up. So here, this is what teams are playing in this image. And then I'm going to close the first dictionary, which is essentially the text prompt. And then the second dictionary, I'm going to open it here, and it's going to have role as well, user. So here I'm specifying who I am. And then content will be type. I think it should be like this. And I'm going to set image, input image. So again, what we're doing here is we're defining first the first input, what teams are playing in this image, and then we're defining the second input, and then I'm going to use the image URL, and I'm going to say it is my image URL, as you can see here, and I'm going to close it here. I think we may have an indentation issue, so I have tip. Oh, I forgot to add a dictionary here. It's one of the things that is a bit annoying with these APIs, that they have a lot of dictionary trees. So I'm going to close it here. Okay. And then I'm going to close my. So as you can see, what I did here, let's see first if the code is correct. Response dot output text. It is running. And yeah, the teams playing in this image are the Cleveland Cavaliers and the Brooklyn Nets. So what we did again, we created using the responses API. The model we used is GPT-4o, and the input was a list of essentially 2 dictionaries. The first dictionary was the text prompt, which is what teams are playing in this image. The second dictionary takes in a content key, and the values is a list containing a dictionary that says what is the type, an input image, and an image URL. And we can input multiple images here, right? So if I do comma, add an image, using another dictionary, it works the same. Now I'm going to start with this is already stuff that you're used to with the chat completions API, for example, or the assistance API. But now the next thing I'm going to do is actually use web search, and I'm going to use tools. So what you need to know here is I'm going to use web search to be able to perform web search on the prompt that I'm using. And it's a relatively easy way to do so. Now I'm going to create a new response object, and then I'm going to create client.responses.create. Same paradigm I've been using as before. And I'm create my new model, GPT-4o. Tools that I'll be using. So this is a new argument that I'm using here. I'm going to create a list first, and then a dictionary takes in as input. So the first tool I'm using is type, and it is web search preview. You don't need to know necessarily the syntax. I'm getting a lot of this from the documentation. Just check out the documentation on how to approach this, and then you'll be good to go. And then I'm going to close my tools use list here. And then for input, I'm going to say, what was a positive story? Actually, instead of what was a positive story, what is the latest information on the stock market today? And then I'm going to print response output underscore text and see what happens. Okay, so this is the main story of the jour on the stock market, which is the US market is experiencing volatility by recent economic data and trade policy developments. Stock market information for the S&P 500 ETSP Trust currently changed one. Market performance, key influences, inflation data, trade policy, which is the main reason. President Donald Trump's announcement of 25 price on steel and aluminum imports has raised concern about potential slowdown in inflation. And then, yeah, investor sentiment. And you can see here the links and the citations, which is all you need to know. So very nifty use of web research. The second thing I want to show here is file search, which is also a really interesting way of getting access to files using a vector store. And to be able to enable vector search and to upload PDFs that get you to your that you have your to be able to use file search on, what you need to do is go to the OpenAI API platform that you see here. Go on dashboard. I want you to go to then storage. Let's avoid this error here. And then on vector stores, I want you to create a new vector store, as you can see here, right? Now I'm going to just press X here and go back to the original one that I created. And then you all need to do is just add files, right? So you can add your file here, so on and so forth. And this is the file that you can use in your vector store. And then what you need to do after that is copy the vector store ID, and you can see how much it's costing you per day, so on and so forth, right? And that's really all you need to know when it comes to creating a simple vector store using the OpenAI platform. So I'm going to just leave this vector store API, this vector store ID here. And then what you're going to do after that is similarly create a new response object. I'm going to create client.responses.create, similar as before. My model is going to be, just to make sure that it's a bit more cost effective, I'm going to use GPT-4o mini. And my input is going to be, now if you notice the file, just in case I didn't cover this, the file that I've uploaded is DeepSeek v3. It is the DeepSeek v3 research paper, which was released, I think, late December, which at this point feels like forever ago. And then what I'm going to ask it is, summarize the DeepSeek v3 paper in depth. And tools I will use is, so I'm going to create my list, as you saw, and then inside of the dictionary, I'm going to say my type of tool that I will use is file search. So here I'm specifying that I want it to do a search over a particular file, and the vector store IDs will be a list because we can actually access many vector stores, but I'm accessing one here just for the sake of simplicity. I'm going to paste my vector store ID. And then what I'm going to do is first print the response to show you what the process looks like behind the scene. And I'm going to break line just to make it cleaner to view. And then what I'm going to do is print the response output text. Okay, so first thing that you get, as you can see here, is the response object, which has a lot of different elements within the object itself. But the thing that I want you to focus on is the fact that it found the file name deepseek_v3.pdf, right? And then it created the output. And the output, as you can see, is here. The DeepSeek v3 paper presents blah, blah, state-of-the-art mixture model, which is 671 billion parameters. That is true. 37 billion activated, right? And yeah, I'm not going to go through the remaining details, but yes, it is essentially accessing the content within the vector store and using it in the output. So if we were to put it all together here, right, where we use web search plus multimodality, for example, right, you can actually do that relatively simply. So what we're going to do in this example is that we're going to give the OpenAI API an image, and then we're going to give it a prompt to come up with keywords related to the image and search on the web using the search tool for any news related to the image itself. Now, the image is a picture of a cute cat, as you can see here, right? And then what we're going to do is we're going to create a new response variable. And I'm going to call it, just for some specificity, response underscore multimodal. So I'm going to create here a responses.create function. My model will be GPT-4o. The input will be a list. So I'm going to break down the list. First, I'm going to define a dictionary where I'm going to create role user. And then content is a list again, because I'm going to have multiple prompts. The first one is my text instruction. So this here, I'm going to create another dictionary. So here, the type is input text. So here I'm defining that this is a text prompt. And my text is the prompt that you see here. Come up with keywords related to the image, summarize the findings, cite the courses. So I'm just going to add here prompt. I'm going to close the dictionary, and then I'm going to open a new dictionary, which is for the image input. So the type here is image, input image. Sorry about that. And then the image URL is, guess what? My URL that you see here. And then I'm going to close the list. I'm going to improve the indentation here. And then once I close the list here on the input, I'm going to add tools. So my tools here is type, web search, and then I think I may need to delete this. I also need to delete this, that you can see here. So let's just double check my indentation is working correctly. My tools here is closed. My input is closed. My input is closed here. Okay, I think this should be good to go. So I'm gonna run this model. It's gonna show the images again. And then what I'm just gonna do is, and again, you don't need to dwell on the syntax here. I just got this from the documentation. See what happens, just to see for the full response structure in JSON. Let's hopefully see if it worked. And you can see here, web search is complete. It looked at it determined what the keywords were based on the image. Keywords related could be cat, tabby, stray cat, cat behavior, cat welfare. I'll use these keywords to search for any recent news articles related to them. Let's see what comes up. And then you'll be able to get, search results. Tabby cat reunited with owners in California 12 years after running away. I thought he was dead. ABC 13 Houston. Wow. 12 years after running away. That is a lot. And then missing New York tabby cat reunited with after 10 years. What's up with these stories? And yeah, so lots of interesting stories about cats being reunited with their owners, which is really heartwarming. And yeah, as you can see here, the response was recent news related to include several heartwarming reunions and notable events, so on and so forth, etc. Now, if I want to just show you what the output text looks like, it's here. Based on the image, keywords related to it could include cat, tabby, stray cat, blah, blah, blah. Let's see what comes up, recent news, so on and so forth, etc. Now, this concludes this part of the responses API. We are planning on doing more videos about this in the future to show you how to build retrieval augmented generation pipelines, so on and so forth. But I do want to make sure that you are at least get a flavor of what the responses API looks like. Now, we can actually go to the more exciting aspect of this coding video, which is the Agents SDK. Now, the Agents SDK, what it does, that allows you to build specialized AI agents that can handle complex tasks. So first, what I'm going to do, and actually simplifies the agent quite a lot. So what I'm going to do is create a history tutor agent. Again, all of these examples are taken from the OpenAI documentation, so I highly recommend that you check them out. But I want to make sure that we are building something relatively simple here. So I'm going to create a history tutor agent. And to be able to do that, I'm going to use the agent function that we imported earlier in our import part. And what I'm going to do is I'm going to call this the history tutor. And then I'm going to do a handoff description. And what this does is it just describes what the agent does, especially for the handoff process that we will see shortly. So here, specialized agent for historical questions. And then the instructions here, these are essentially what the agent is supposed to do. You provide assistance with the historical queries, explain important events and context clearly. And what I'm going to do is I'm going to then run the agent. So I'm going to create this result function, but object, sorry. And I'm going to use await runner.run. So here I'm using asynchronous running. So I'm just running essentially the agent. So a history tutor agent. And the question that I'm going to ask it is, who was the first president of the United States? And then I'm going to print result, final output, as you see here. Okay, the first president of the United States was George Washington. He served from 1789 to blah, blah, so on and so forth, etc., yada, yada, yada. Now, one thing that was important that we covered earlier in the video is that OpenAI now provides tracing, so observability over what your agent is doing and how it's performing. So all I need to go do is go to my dashboard, as you saw here. I just need to go on dashboard. I need to go to traces. Let's remove this. I'm not sure why they have an error. But as you can see here, at 1643, my agent ran for 3.34 seconds, and it was the history tutor. And I can press on the trace and get additional detail. And you'll see here what the response was. The user inputted who was the first president of the United States, and here was the output. So I have detailed log over everything that's going on with my agent, who's using it, so on and so forth. And you can see the system instructions are already there. You provide assistance with historical queries, so on and so forth. And essentially, that's the traceability that we're going to be showing off shortly. Now, the second thing, let's say I want to create another specialized agent. So this one is specialized on math, right? So what I'm going to do is I'm going to also create a new agent called Math Tutor Agent. And what this does, I'm going to open up a new agentic function. The name is Math Tutor. The handoff description is Specialist Agent for Math Instructions. And then the instructions are, you provide help with math problems, explain your reasoning at each step, and include examples. Right? So again, really simple syntax here. And then I'm going to also do the same logic that you saw. I'm going to use await runner.run. So I'm running the agent asynchronously. I'm going to name it Math Tutor Agent. And what is my prompt? What is the derivative of x squared minus 1? So it should be 2x, if I'm not mistaken, if I remember my derivatives well. And I'm going to do print result.final output, similar as you saw here. So let's see how it performs. Okay, to find the derivative of function fx, and then we'll use the power rule of differentiation, blah, 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 blah. The derivative of 2x squared minus 1 is f prime x equals 2x. So we're good to go. And I still remember my math well. Now, let's say you're building an agent where a homework helping agent, where essentially the user can ask either a history question or a math question, and you don't know which agent to hand it off. This is where the triage logic comes in. So what I'm going to do here, I want to show it. I don't need to do this, but I want to actually show it just in the same cell, just to give you an overview. So I'm going to redefine my history tutor agent. I'm going to redefine my math tutor agent, as you see here. But I'm going to create a third agent, which is called a triage agent. And what this agent does is that it decides which agent it should delegate the task for based off of the input. So I'm going to create a triage agent called agent here. And the name is going to be called triage agent. The instructions for this agent are hand off to the appropriate agent based on the nature of the request. And the additional thing that I'm going to be defining here is a handoffs argument. And what this does is takes in as a list 2 agents, which are the history tutor agent and the math tutor agent. So if you see here, we have for these agents a handoff description. Based on the description of these agents, the handoff logic will be determined by the triage agent LLM. And this makes it a really interesting way to be able to build these types of agentic workflows. So what I'm going to do is actually I'm going to create result. I'm going to create 2 results here. So I'm going to do first runner.run triage agent, right? So same logic that we've been using. But first I'm going to ask it, what is the derivative of x squared minus 1? And then I'm going to say print result output text. Or final output, sorry about that. And then I'm going to add it again, but this time I'm going to ask it a history question. So, who was the first president of the United States? So, as you can see here, what's happening behind the scenes? We have a history tutor agent that we define, we have a math tutor agent that we define, and then we have a triage agent that, based on the input, decides who to delegate this task to, whether it's the history one or the math tutor one, according to the logic that we defined on handoffs here. So I'm going to print it out. And as you can see here, it provided the answers for the derivative of the function, which is, x squared minus 1, it is 2x. And then for the President of the United States, it was George Washington. Now, what's important to note here as well is if I go back to my traces, and if I refresh here, you'll see that the model ran a triage of math tutor to history tutor, right? So we have the triage agent handed off to the history tutor, and then we got a response from the history tutor, and then the triage agent handed off to the math tutor and handed off, and we got a response from the math tutor. And this is where these traces functionalities are really interesting. It's because you're able to log back almost everything, especially for debugging or understanding where things are going wrong. Now, the last example I'm going to show is how to use guardrails to control agent behavior. And this is essentially in this kind of homework example, if someone asks the model something that is completely unrelated to homework, how can you stop the model in its track, the agent in its track, so that you're not spending any input or output tokens, and more importantly, so that you're not having any undesired output. So what we need to do first is define a structured output format using Pydantic, which we imported early for our agent, right? So this ensures that any agent outputs a specific format. So I'm going to build here an object called homework output, which takes in here base model. So this is a class, and it essentially says is homework is a Boolean. So what this means is that whether the query appears to be homework related or not, and then the reasoning behind the determination. So this outputs the model reasoning here. And then what we're going to do is we're going to create a guardrail agent. So I'm going to call this guardrail agent. And again, I'm going to use the same agent functionality. So name is guardrail check. The instructions are check if the user is asking about homework, and its output type, like the type of content it outputs, follows the, let me fix this here, homework output class that you see here. And then we have our math tutor agent that is already defined. We have our history tutor agent that are defined. But then what I want to do is define the logic of the guardrail, right? So for this to run asynchronously, I'm just going to use async, and I'm going to define my homework guardrail. It takes as input, this is according to the API, a context, an agent, and input data, which is the prompt. And then first thing that we're going to do is run the guardrail agent that we just defined, right? So the result here is, and we're using a wait for it to be running asynchronously, run guardrail agent. We're going to use input data. And then the context is the context from the existing context in the chat, right? Which is, again, the homework guardrail gets from the triage agent and the conversation, the input data. Now then, second thing, we're going to deliver the final output of the guardrail agent. So here it's result.final output. And I'm going to use final output as, because I want it to be formatted according to this homework output class, right? As you can see here. Oops. Okay. And then what it needs to return is a guardrail function output object, which we've already imported, right? And here the output information is the final output. that we got, right? And then the tripwire will be triggered if the final output is homework is not true, right? So actually is homework like this. So as you can see, I'll just explain this again. What's going on? We define the homework output class, which essentially structures the output of the Guardrail agent into, is this homework, yes or no, and what is the reasoning, right? We created a Guardrail agent, which checks if the user is asking about homework, and the output type here is homework output, so that it defines its output according to the structure. Then we defined our specialized agents as before, the math tutor agent and the history tutor agent. And then we defined a Guardrail function. And what this function does at the beginning, it runs the Guardrail agent on the input to see if it's homework related, right? So as you can see here, it's running the Guardrail agent on the homework to see if it's related. Then what it does, it sparses the result into the structured output format that we had, which is yes, it is homework, no or not. Then we return our Guardrail function output that indicates whether to proceed, right? So if homework is false, the tripwire is triggered, right? Otherwise, you can continue. And then what we need to do is just create a triage agent, but with a Guardrail. So I'm going to create a new triage agent, and I'm going to call it agent. The name is called triage agent. I'm going to use the agent function here, sorry. And then instructions are going to be, you determine which agent to use based on the user's homework question. My handoffs will be same as before, history, tutor agent, and math tutor agent. But the additional thing that I'm going to do is I'm going to add input guardrails. So here I'm going to define a list. I'm going to create an input guardrail object, and then the guardrail function is which one? The homework guardrail function that we defined here. So here, essentially, what we're providing the triage agent is an input, is a guardrail logic, right? So if the query is not related to homework as determined by the guardrail agent, then we stop the loop, essentially. And then all we need to do is test on a homework-like question. So here I'm asking the triage question, who was the first president of the United States? So let me take this here. Let's see how it performs. The first president was George Washington. And if I go to my traces, we ran a triage agent. There was a guardrail check, and it then gave it to history tutor, and it took about 8.74 seconds. Now, if I go back and I then say, what is life? Which is unrelated to homework, but a very important question. And then we're going to run a try except statement that says the guardrail has been triggered. And we're going to say, guardrail triggered, the guardrail has been triggered, import guardrail tripwire has been triggered. And if I go back to my traces, let me refresh here. The guardrail check, it stopped there at the guardrail check. So we didn't use any output tokens, and we were able to have a relatively good agent in a short amount of time. Now, this wraps it up for this video on the new OpenAI API SDK, OpenAI Responses API, and the new OpenAI Agents SDK. If you want to learn more, we highly recommend that you check out the resources in the description below. We will be creating more videos on additional projects that you can build with the Agents SDK and the OpenAI Responses API. And do let us know in the comments, what would you like us to build? What are the most important tools and packages you want us to cover? And with that said, happy learning and have a great week.